Hey everyone, when we start chapter 9, we're going to be talking a lot about quadratic functions. The entire chapter is about quadratic functions. What is a quadratic function? Well, when graphed, it looks like a parabola, or this fancy schmancy U shape right down here. By the way, that U shape can also point down. Fun fact. All right, so let's get some definition stuff. I'm going to do 9.1 in 2 videos. The first one is lots and lots of definitions. So to start with, this is the standard form of a quadratic function. By the way, a, b, and c are all going to be numbers, like 2x squared minus 4x plus 7, or any combination thereof. Now this squared part, this is what we're going to call the quadratic term. Wait a minute, that sounds familiar from chapter 8. This we are going to call the linear term. And last but not least, this is called the constant. You might notice that this back half looks kind of familiar. It's kind of the same idea there. That's why we call that the linear term, and I don't know why that's still actually going to end up being the y-intercept. I don't know why we don't call it the y-intercept, but we call it the constant. All right, so let's actually do something with these. Or more definitions, I guess, first. First things first, the point where the graph turns around is called the vertex. So over here you can see down here, that is the vertex right there. The other thing these are going to have is an axis of symmetry. That is this imaginary line here on the graph that if I could pick this graph up off the computer, fold it in half along that dashed line, this half would land exactly on top of that half. Okay, that's the little mirror part. So then the other thing is going to be the y-intercept, and unfortunately this little sign there is kind of blocking it, but the y-intercept is where it crosses the y-axis, just like on our linear graphs. So on 2a, it's going to ask us to find those 3 things given the graph. So here's the vertex. So what is that point? -1, 3? Okay, that's just a point. Vertex. Let's label that vertex. Axis of symmetry. I usually just write axis of symmetry is always going to be x equals x of vertex. So x equals -1, right? That would be this vertical line right there. And last but not least, the y-intercept, you just put y-int, would be 0, 2. Because it would be this point right there, 0, 2. There we go, highlighted them so that they're easier to see. All right. Flip the page on your notes here. This table here is going to be your very, very best friend throughout this part of the chapter, and maybe even the next part too. Because it's all about, it gives all those definitions of things that you have to know. So the one thing I want to add to it is on the vertex, I forgot to put in that this x right here is -b over 2a. So, as we go to do a problem, I'm going to try and keep that table where we can see it because it's super handy. Find the vertex and equation of the axis of symmetry and the y-intercept of each function. So vertex. This time I don't have a graph, but I go up to the chart and it says the vertex means x is -b over 2a. Okay, so as I look down here, if it's always ax squared plus bx plus c, then -b is, the b is 6, 2 times -3. It's really hard to write that small. that zoomed out. Okay. So then I simplify this. Negative 6 divided by, that's going to be negative 6, is going to be a happy 1. And the other thing I don't necessarily have written down with this vertex is plug this answer back in to find y. Yeah. So what that means I'm going to do is I'm going to take this 1 and plug it right back in to this entire equation here. So negative 3 times 1 squared plus 6 times 1 minus 5. So 1 squared is 1, negative 3 times 1 is negative 3. Plus 6 times 1 is 6. Hey, this is looking easy to solve. Negative 3 plus 6 is a positive 3. Positive 3 minus 5 is negative 2. So my vertex is going to be 1, negative 2. Next up, it asks about the axis of symmetry. Two things that you could say here. First of all, it kind of says on this document that, or on this table, that x equals negative b over 2a, which, hey, isn't that how we found the x of the vertex? And hey, up above, didn't we say that this is always the x of the vertex? I'm going to write that in. X of the vertex. Write that down. So in this case, it would be x equals 1. And last but not least, the y-intercept. How do I find that just on the, just by looking at the equation? Well, come up here to where it says y-intercept, and what does it say? The c of the equation. It is always the c of the equation. Okay, what's the c of this equation on 3a? It's negative 5, so you just have to write negative 5. If you want to write it as a point, it would be 0, negative 5, but the negative 5 by itself is good enough. And that's it for that one. Here, number 4 is going to ask us some questions about the rest of the, or that relate to the rest of the table here. Determine whether the function has a maximum or minimum. For this one, you're going to want to look at both of these two pieces of the table right there. If A is positive, the graph opens up. If A is negative, the graph opens down. Again, what is the A value? 2. Okay. Is 2 a positive or negative number? Positive. So according to my table, if A is positive, the graph opens up. Good information, but I don't care about that. I want to know if the function has a maximum or minimum. So go to the next one, maximum or minimum. If the graph opens up, it looks like this, which means it can go up forever, but it cannot go down forever. If the graph opens down, it can go down forever, but it cannot go up forever. This is a minimum. Actually, I'll do it in a different color. This is a minimum. This is a maximum. Minimum, maximum. So, back on 4a, it opens up, which means it has a minimum. I'm just going to color it in. Okay, state the minimum or maximum value. This needs to be written over here, probably. The minimum or maximum value is the y of the vertex. The minimum or maximum value is the y of the vertex. So that means I'm actually going to have to find the vertex of this equation. Starting with the x. The x is negative b over 2a. And since b is a negative 4 this time, I'm going to plug in negative 4. but a double negative just makes it 4 over 4, which is 1. So then I'm going to plug that 1 back into the original equation. Oops, forgot parentheses there, didn't I? 2 minus 4 minus 1 is negative 3, right? 2 minus 4 is negative 2, minus 1 is negative 3. So the maximum or minimum value is 3. State the domain and range of the function. Let's go up here and read. Domain, that is how far left and right the graph can go. It will always be all reals. Oh, that's easy then. No matter what, I can just say all reals. Range. I'm suspicious this will not be so easy. How far up and down can this graph go? If it opens up, then the range is y is greater than the y of the vertex. If it opens down, then the range is y is less than the y of the vertex. Well, I suppose that makes sense. If it opens up, it's saying y is bigger than the vertex. If it opens down, it's saying, oh, that was a bad parabola. There you go. If it opens down, it's saying y is less than the vertex. That makes sense. All right. So since this one has a minimum because it opens up, if it opens up, then the range is greater than the y of the vertex. So it looks like my range is going to be, my range is going to be y. Try and get where you can see that too. Greater than or equal to the y of the vertex, which is 3. Okay, that's all of the definition stuff on this piece. Next up will be actually graphing them. Woohoo!